Welcome back, people. And we are in our Unit 6, and that is all about reactions. Last time you learned about chemical equations and how to balance chemical equations. Now we want to go one step further, and we want to not only balance equations, we want to first predict the products. Aye. And how do you do that? Well, from my standpoint, you just have to memorize about 25 reactions. Egads, yep. Let us start here. Consider the synthesis reaction between solid magnesium and chlorine gas. Predict the products. Yikes. All right, let's start off with some notes. We have reactions, and we said, hey, we can have chemical equations. That's a way of representing a reaction. We talked about symbols and stuff. And now we want to talk about the types of reaction. And one type of reaction is something that we call a synthesis reaction. Synthesis reaction, aka, what does aka stand for? Also known as a combination reaction. So some people will call it synthesis, and some people will call it combination. It has the general form of A plus X yields AX. And A and X could be elements or compounds, but the idea is I'm going to take two things, two reactants, and out of those two reactants, I'm going to form one product. And so that's the way I recognize a combination or synthesis reaction, is that I form one product. Okay, good. Now, there are 5 types of synthesis that we want to learn. Type number 1 is going to be when I have a metal plus a non-metal, and they're going to react to form a binary ionic compound. Okay, so metal plus a non-metal. We look at our first example. We have what? Magnesium. Okay, magnesium is a metal, reacts with chlorine gas. Chlorine gas is a non-metal. And then what are they going to produce? Okay, let's see here. Oops, I have a metal and a non-metal. So we said we had what? Magnesium, solid, plus chlorine gas. I brought clay. That means it's diatomic. And it's going to form what? A binary ionic. Okay, that means it's going to form magnesium as an ion and chlorine as an ion. Now, magnesium as an ion, you'll recall it's a group 2. That means it forms a 2 plus. Chlorine as an ion is a group 17, a halogen, -1. So how do I make that a balanced formula? Well, I'm going to need 2 chlorines. Its state is going to be solid because ionic compounds are solid at room temperature. Now we have to balance it. 1 magnesium here, 1 magnesium here, 2 chlorines, 2 chlorines. Okay, so here is my reaction. I have magnesium plus chlorine yields magnesium chloride. All right, just state that again. Magnesium plus chlorine gas is going to form, it's a metal and a non-metal. It's going to form a binary ionic, meaning only 2 things, compound. Here, you guys give this one a try. Bring me back when you're ready. Okay, I have solid sodium with liquid bromine. Sodium is a metal. Bromine is a non-metal. Oops, yikes. A metal plus a non-metal is going to form what? A binary ionic. My metal is sodium, solid, plus bromine I brought. Okay, bromine is diatomic, liquid, yields, now it's going to yield what? NaBr. What's my Na charge? Usually when it is a ion, it's +1. Bromine, when it's an ion, is 1 minus. Good, so what's my ratio? 1 to 1. So that indeed is my compound. Now what do we need to do? We need to balance it. I have 1 sodium here, 1 sodium here. That's great. I have 2 bromines here, but I only have 1, so I have to do this. Now I have to go back and work on my sodiums again, put a 2 there. And so this would be my predicted balanced equation. Woohoo! Yeah, voll. Let's draw a little piggy. Well, who knows? There we go with wings. Well, that's a strange pig. And put some legs on him. Oink. Ooh, dive bombing you. Get a little tail. All right, moving forward. Consider the reaction of solid calcium. Okay, that's a metal with oxygen gas. Oxygen gas. Now, that is a non-metal, but we also have a special place in our hearts for oxygen. So we really consider this another type of reaction. We consider this a metal plus oxygen, and it's going to form what? A metallic oxide, a metal oxide. Okay, nothing really special here. It's a form of an ionic compound. What did we say? We have calcium and oxygen. Okay, let's write down an example here. Calcium and oxygen. Calcium, solid calcium plus oxygen gas, and it's going to form a metal oxide, which is really just what? That's really nothing but a binary ionic, right? So I have calcium, oxygen. Calcium forms a 2 plus, oxygen forms a 2 minus. It means it's a 1-to-1 ratio. Good. I have written my formula properly. It's going to be a solid. How many oxygens? I need to put a 2 here and a 2 here. There we go. Metal plus plus oxygen forms a metal oxide. Cool. All right, let's write this down. Calcium solid plus oxygen gas yields what? Calcium oxide. I need 2 of those, 2 of those. Ionic compounds are solid in the absence of water. Good. You try this one. Well, reaction of solid sodium. Sodium is a metal with oxygen. Okay, a metal plus oxygen is going to form a metal oxide, right? A MOX. Sodium Na plus, it's a solid, plus O2 gas is going to yield what? Well, sodium and oxygen. Sodium is a 1 plus, oxygen is a 2 minus. It means I'm going to need 2 sodiums here. It's going to be a solid. Now now we get a little more complicated. I've got 2 oxygens here. I need to put a 2 here, which means I need 4 sodiums there. There we go. That would be correct. Now, there is something else that sodium and oxygen make, but you'll have to wait till AP chemistry for that. This is good enough. Moving on. Next, consider the reaction of solid calcium oxide. Is that a metal? No, that's not a metal. That is a MOX, right? That's a metal oxide and water. Okay, that doesn't fall into a metal and a non-metal. It doesn't fall into a metal and oxygen. This must be, yes it is, a third type of synthesis reaction. Good. Number 3 is a metal oxide. As you see, I call it a MOX, plus water. And you're going to notice that I like to write water as HOH, and you'll come to understand why. Yields what? It yields a metallic hydroxide. And a metallic hydroxide really is something else, which we call a base, right? It yields a base. I like to go with metallic hydroxide. It's a little more descriptive. We said what? We have calcium oxide, CaO, and it's solid, plus HOH liquid. And what does that form? We said it's going to form a metallic Ca hydroxide. Okay, my calcium is a group 2, so it's a plus 2. Hydroxide is a 1 minus. That means what? I need 2 hydroxides. Now the state here, we'll learn later how to interpret that. For the time being, we're going to go with solid here. You just have to trust me on that. We have to balance this. Is it balanced? I have 2 hydrogens, 2 oxygen. Yeah, it's balanced. Here we go. Calcium oxide plus water forms a base, a metallic hydroxide. Let me complete my parallel here. Let's write down our example. Calcium oxide solid plus HOH is going to do what? It's going to yield calcium hydroxide solid. Cool. All right, moving on. So you guys try this one. Zinc oxide and water. Okay, here we go. Zinc oxide, that is a what? That is a metal oxide and water. A metal oxide and water. Metal oxide plus water is going to form what? A metal hydroxide. And we don't know what that X is. Could be 1, could be 2, could be 3. Zinc oxide. Okay, zinc is always plus 2, so that means it's CO, solid, plus HOH, right? And that's going to be a liquid, and we're going to yield what? Well, a metal. What's my metal? Hey, zinc's the only metal there. Hydroxide. Zinc, we said, forms a 2 plus. Hydroxide is a 1 minus. That means I'm going to need 2 of these dogs. Good. 2 hydrogens, 2 hydrogens. Looks wonderful. There we go. It's solid. And this is our answer. Now, are you weak at polyatomics? Oops, that's not a good thing. Are you weak at naming? Are you weak at from doing the last unit or not doing the last unit? That's a problem. You need to know how to name things. You need to know how to write formulae. If you can't do that, like I say, you're in a world of hurt in this unit. Next, consider the reaction of carbon dioxide gas and not carbon dioxide gas oxide, sorry. Get rid of that. Carbon dioxide gas and water. Okay, so this looks pretty simple. It's water. And it is what? Metal oxide. Whoa, 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 whoa. Since when is carbon dioxide a metal oxide? Carbon's not a metal. No, no, no. This would be a non-metal oxide. Egads. What does that form? Well, we're going to have more notes. Oh! And what is it? Here we go. 4. Not a metal oxide. I'm going to change colors because this is so important. It is a non-metal oxide. A non-metal oxide plus water. And a non-metal oxide plus water is going to form not a base, but it's going to form an oxy acid. Cool. Are you telling me there's a parallel here? Yeah. A metal oxide and water forms a base. A non-metal oxide and water forms an acid. Cool. That's really neat. Good. Now, what are non-metal oxides? Well, it's non-metal with an oxygen, something like carbon dioxide, carbon monoxide. What do you think? Sulfur trioxide, sulfur dioxide. NOx, nitrogen dioxide, nitrogen trioxide. Anything that has a nonmetal and oxygen on it is a nonmetal oxide. Okay, and what are we dealing with here? We said we have calcium, carbon dioxide gas plus water. Now, what am I going to form? Well, I'm going to form an oxyacid. That means I'm going to form an H. And what is an oxyacid? Well, it's H plus an oxyanion. Now, what oxyanion can I form from carbon and oxygens? Well, carbon and oxygens, do I know? Oh, yeah, I know an oxyanion. It is carbonate. I've memorized that. Aha. In fact, it's the only oxyanion that I know that has carbon and oxygen in it. So that means it's got to be carbonate. Carbonate is a -2. Each hydrogen is a what? +1. How many hydrogens do I need? 2. Cool. It's a liquid. And it's balanced already. And my acids, when water is present, and here's water right here. If water is present, my acids are aqueous. Or if you say aqueous, that's fine. There we go. So carbon dioxide, ooh, we're going to go with multicolors. Carbon dioxide gas, liquid, what did we say? It's going to form H2CO3. I wish I knew how to name that. Let's see. H230. How do I, this is a what? Oxyacid. How do you name an oxyacid? Does it use hydro? No hydro? No hydro. So it's just going to be what? Carbon. Now what? This is 8. Carbonate. When it's 8, what's my acid name? It is carbonic acid. There we go. You guys remember that. So carbon dioxide plus water form carbonic acid. Woohoo! Consider the reaction of sulfur trioxide gas. So you do this one. Bring me back when you're ready. Okay, you're ready already? Wow. Sulfur trioxide gas and water. What is this sulfur? That is a nonmetal oxide. Ooh, nonmetal oxide plus water. So a nonmetal oxide plus water is going to form what? An oxy acid. Sulfur trioxide gas plus water is going to form what? Well, what oxyacid? I know it's going to be an H. Oxyacid, it has to have an oxyanion. And what oxyanion do we know is formed from S and O? Well, there are two. There's SO3 2 minus and SO4 2 minus. Now, I'll tell you in this case, this oxygen, we're going to need something here. Let's see. Yeah, this oxygen is going to come over here, right? And so we would have how many oxygens? 4. Now, in this case, it's going to be sulfate. In the future, I'll tell you, there's another way to understand that, and just write this down and we'll explain it later. The oxidation state of my nonmetal stays the same. And you'll figure that out later. I'll teach you oxidation states later. But this oxidation state of sulfur is going to stay the same, and that's why it forms SO4 2 minus, not SO3 2 minus. So it's H2SO4 aqueous. That would be the correct answer. And that was a little tough, folks. If you got that right, you're doing really well. Good. 2 more, and then we'll take a break. Consider the reaction of solid sodium oxide and carbon dioxide gas. Cool. Calcium oxide, that is what? Calcium. Oh yeah, calcium's a metal. Oxygen, so that's a metal oxide, and carbon dioxide is, oh, that's a, yeah, non-metal oxide. Do we have anything where I have a metal oxide plus a non-metal oxide yielding something? No. That means to the notes. Here we go. The last reaction that you have to memorize for synthesis. Wow, and we're just beginning. Metal oxide plus non-metal oxide is going to yield, I hope this isn't anything hard. Well, it's not. It's just going to yield a polyatomic ionic compound. Oh man, is that all? Sure. You've memorized your polyatomic, so this will be a piece of cake. And what was our example? I forgot already, my short-term memory. It is calcium oxide and carbon dioxide gas. So let's go ahead and complete our example here. Calcium oxide plus carbon dioxide gas. Now, it's going to form a polyatomic ionic. That means it's going to form a metal with, it's going to be a metal plus an oxyanion. Good. What's my metal? Well, my metal is easy, Ca. What's my oxyanion? Well, I have carbons and oxygens. That's going to form what anion? Oxyanion. Carbonate. Calcium's a +2. Carbonate is a -2. And there we go. Calcium oxide plus carbon dioxide yields calcium carbonate. Zoink. Oops. Let's finish this. Calcium oxide solid plus carbon dioxide gas. Zoing. What do we form? Calcium carbonate. Woohoo! Every time I say that, I think I deserve a donut. Ooh, donuts. And here we go. The last one before we take a break. The reaction of solid iron to oxide and sulfur trioxide gas. You guys give this a try. Bring me back when you're ready. Iron to oxide, metal oxide, sulfur trioxide, non metal oxide, right? So if I have a metal oxide plus if I have a MOX and a NUMOX, what do I form? I form a polyionic compound, a PIC. Good. What's my metal oxide? Iron 2. What does the 2 mean? Well, that means my charge, my ion is a 2. Oxygen, what's the charge on an oxygen? -2, so just like this. It's solid. Plus what? Sulfur trioxide gas, SO3 gas. What's going to happen? Well, this oxygen is going to fly over here and hook up with my sulfur trioxide, meaning what am I going to make out of this? Sulfur with 4 and a 2 minus. I'm going to make a sulfate. And so it's going to be iron sulfate. Sulfate it's iron 2, right? Plus 2, sulfate is a -2. It's a 1-to-1 ratio. That's going to be a solid. Good. And is it balanced? It all looks like it's balanced. So there you go. Those are my big 5 synthesis reactions. Next time you come back, we are going to do decomp. Goodbye.